Right. This is our second part for the last video. See here. Now you have, I am considering this total equation as y, or you can do this with the other part. As I said, in our final resultant solution, right? Let's say VF, our final resultant solution's volume is 100 centimeter cube, right? It is actually 100 centimeter cube. So now we are going to have a new concentration. Before going to that, we're going to have a new concentration, right? So before going to that, we'll consider this part. Let's see the reaction here. So HCl, which is a strong electrolyte, let's say strong acid instead. Strong acid will completely dissociate, giving H plus aqueous and Cl minus aqueous here. They'll give H plus aqueous and Cl minus aqueous. So I consider the whole equation as y. So let's say if the same remaining moles are there here, the same thing will be here. That's what the Stoichiometric ratio says. If 1 mole of HCl aqueous dissociates, it will completely dissociate, giving 1 mole of H plus aqueous and 1 mole of Cl minus aqueous. Okay, got the idea? But they said they have given another clue. pH of the resultant solution is 2. Right? So you guys know, if pH is 2, you have to keep in mind. You know this equation, pH is equal to minus log 10 H plus aqueous, right? H plus aqueous over 1 m. I'll say y 1 m came. So if for pH you don't have any unit, right? So if you divide the concentration with 1 mole, then you can't get any units here. That's why pH is given 2 here. Understood? So if pH is 2, so according to your maths knowledge, if you bring this minus here, you will get minus 10, minus 2 log 10 H plus aqueous here. Here you have 1 mole. Bring it here. Now you can write this thing in terms of minus 2 here. Right? So what you'll get? H plus aqueous. You have to know this. Without this part, you can't do the physical ionic equilibrium part. This is a general idea. So you can write this in terms of 1 into 10 to the power minus 2 mole decimeter minus 3, which is equal to, if you bring another 0 here and bring the decimal point over here, you get 10 to the power minus 3. So 10 into 10 to the power minus 3 mole decimeter minus 3. You can write in this way. Why I took this? Because I have here 10 to the power minus 3. That's the main reason I took this one. Okay. Now see here. See the twist. Here you have 10 into 10 to the power minus 3 mole decimeter minus 3 of H plus in the resulting solution. Right? Now you have the moles here now. You have the moles here. So if you can either do one thing here, you can bring this to the number of moles that you have in the resulting solution, or you can equate the concentration of the resulting solution. You can do it in 2 ways. One, you can either simplify, either equate the concentration, right? You can do with the concentration, or you can do with the number of moles also. You have no problem. You have no any problems, right? You can consider this one for 100 centimeter cube. Then you can bring this there, and you can do the same thing here. Or you can keep this concentration here and convert this one to 100 centimeter, divide this one by 100 centimeter cube to get this exact concentration equal to this. You can do any of the ways. Answer is going to be the same, right? Keep in mind, everything is going to be easy here, right? You can do in these 2 methods. No harm. Answer is going to be the same, right? So this is here. So I'll do in both the methods, right? Some of you will have some curiosity, right? How can that be equal? Okay, let's do it. So you have the y. I didn't raise that part. So let's keep it. Right. Now the resulting solution of this one is going to be 10 to the power minus 3. Now I'll do in terms of the concentration. Okay, let's do it in terms of the concentration here. In the terms of concentration, now we have y, the final volume. Final volume of the system is actually 100. So new concentration of HCl, right? New concentration of HCl is equal to y over 100 into 10 to the power minus 3 decimeter cube. What I can do is I can bring this thing over there in terms of y. So it will be there 7 minus 30x right into 10 to the power minus 3 mole decimeter minus 3 mole divided by 100 into 10 to the power minus 3 decimeter cube. So the moles are there now. You have the moles. We're dividing this one by the final volume there. So you will get 7 minus 30x over 100, right? Capital M. So this M is going to be equal to this. So this is going to be equal to this. So I'll bring this answer here. Simple now, because here this concentration is going to be equal to this. This is also going to be equal because concentration is equal to number of moles over volume. The volume of the final system is not going to change because it's 100 now. So this is going to be constant. So concentration is directly proportional to N. So you can consider the number of moles because you have to consider the number of moles when you're going from reactants to products or products to reactants or between reactants to reactants or products to products. You will have to see the stoichiometric ratio. So usually you will do with number of moles. So I'm going to do with the concentration. That's easy, right? So this 10 to the power minus 3 is equal to this HCl, the final concentration of HCl. So how much it has to be? 10 into 10 to the power minus 3 mole decimeter minus 3. Bring it over there. Move this 100 over there. So what will happen? 7 minus 30x is equal to 1000 into 10 to the power minus 3. So we'll get 1 is equal to 7 minus 30x. If you bring to this one, this side and other side, you'll get 6 is equal to 30x. So x is equal to 6 divided by 30. So this is actually going to be 2 over 10 is equal to 0.2 m. So what's the answer? Second one is the answer. What's the answer you got? 2 over 10 no. So there is going to be a second answer. This is going to be a second answer. So simple case. So as I said, let me do in the second method also. It's easy. I'll keep the moles there. I have the moles here, right? So I'll do the same thing here in terms of moles. So I'll take the moles here. So we'll get 70 7 minus 30x into 10 to the power minus 3 moles over here. So in the final resulting solution, you're going to get 10 into 10 to the power minus 3 mole decimeter minus 3. What you're going to do is you're going to directly do in terms of moles. So how? So 7 minus 30x into 10 to the power minus 3 7x into 10 to the power minus 3 moles is equal to, right, is equal to wait 10 into 10 to the power minus 3 mole decimeter minus 3, right, into 100, right, 100 into 10 to the power minus 3 decimeter cube, right. So see here 10 to the power minus 3 is there, here already 10 to the power minus 3 is there. This 10 to the power minus 3, 10 to the power minus 3 will get cancelled here, right. You guys can understand here, right. So 7 minus 30x into 10 to the power minus 3 is equal to, I'll not cancel both of these. So 100 into 10, 1000 into 10 to the power minus 3 into 10 to the power minus 3. So you can cancel these two. So what is the final answer? You get 1 is equal to 7 minus 30x. The same answer will come here. Understood? You can do it in these two methods. No harm. As far as you do whatever method that is, you can do either in these two. You can relate them with the concentration or with the moles. The answer is going to be the same one. So exactly you will get 0.2 moles. That is going to be your second answer. Right? Let's see the seventh question in the upcoming next video.